Yesterday we did this example based on the binomial distribution. So we use the probability function, which was that one. Let me write here. Take the probability. A random variable capital X is equal to small x, a value small x. That is the nx times px times 1 minus p n minus x. Okay, so at least how many independent trials was given? Probability of success will be given again. So for each value of x, we can take the probability. Do you remember? Okay. I suggest to you, we have three terms, right? You know, the first one, when you are using the calculator, go to the math key, go to the probability, take the C function when you have a TI-84. What does C stand for? It's a combination. The C was the combination. So look at this. For this one, here is a 1S, 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 one success. We had three combinations which has 1S. Also the other three combinations, two successes, 2S and 2S. Right? You know, actually, the first one, the function of C returned the number of combinations. So why don't you try, if I want to take the probability x equal 1. For example, what does that mean, x equal 1? You know, the random variable x was the number of success. So how many successes? Only one success, two failures. In this case, it can be 3 and 1, or 3C1. How many was 3C1? Do you remember? You can try right now. Go to the math key, probability, take number 3, NCR. How many? 3. Who are the threes? 1S. This one, and this one. 3 combinations. How about the x equal 2? 2 x's. 2 successes. So it should be 3 and 2. Or 3C2, try it. How many will be? I expect 3. Am I correct? 3? Because here is 2 S's, 2 successes. Right? Yeah. So, you know, actually the first one, that is the number of combinations. For each x, 1 success, 2 successes, even 3, the first term returned the number of combinations. Please look at the second one, the second term. Who was the P? What was the probability for? P was a probability for success. Right? And it had the power x. What was the x? number of successes. So now I can say the second term, the P with the power X, it is for the success. You know, before we take the probability x equal 1, it means one success, right? So we took the multiplication, one success and two failures. So yesterday we took 1.8 success. Failures probability was 0.2. Do you remember that? How many? Square. 0.8 times 0.2 times 0.2. And how many combinations? 3. So the very first term, that is a number of combinations. And the second term is this. Is actually, you know, the power was 1 because we had one success. Then how do you think? What is the last term? You know, the probability 1 minus P, it is the probability of failures. And how many n minus x? Now it is the number of failures. So the second term is for success. The last term is for the failures, for this one. The same idea for x equal 2, which was 2 successes. So we take 0.8 square, 2 successes, and 1 failures, 0.2. How many power? 1. And how many combinations? 3 again. So we took 0.8 times 0.8, 2 successes. Additionally, times 0.2, 1.2, well, 1 failure. So that was this one. So simply, you know, the binomial distribution, it just take the multiplication. The first one is how many combinations times success part time and failure part. Yeah. So that was the probability function for the binomial. You know, for the discrete random variable, it's not only probabilities, but also we need the mean and the standard deviation. Here's a mean and the standard deviation. You know, before we applied the 6 steps to get the standard deviation. But for the binomial distribution, the binomial setting, we don't have to apply the 6 steps. Simply, n times p, who is the n again? The number of independent trials times probability of success. Simply, it will be the mean. Standard deviation will be simply square root of n times p times 1 minus p. We don't have to apply the 6 steps. Let me ask you. Then who will be n times p times 1 minus p without square root? You know, before, when we applied only 5 steps, it was the variance. Do you remember that? The variance? Yeah, we had in chapter 3 statistics for the variation, variance, standard deviation, and the range. So without the square root, simply n times p times 1 minus p will be the variance. But finally, take the square root, it will be the standard deviation. It's very simple. It is very simple. So it is a reason why we want to use the given random variable, because we knew everything. How can we take the probability? It's here. And also, simply we can take the mean, and simply we can take the standard deviation. So in this case, You know, the n was 3. I mean, in this example, 5.11. Probability of success was 0.8 to be alive at 65. So simply I can take the mean, mu, n times p. So it will be 3 times is 0.8. So how much will be 3 times 0.8, please? How much? 2.4. What is a 2.4? It is on average. The average of what? When we have 3 people, we can expect 2.4 people will be alive at 65 among the 3. Because you know the chance to be alive at 65 was 80%. So among 3, we can expect 2.4 people will be alive at 65. It's on average, the 2.5. Standard deviation will be square root of n times p times 1 minus p, right? So we have to take 3 times 0.8 times 0.2. I can take 0.2 from 1 minus 0.8. Please take the standard deviation, please. Square root of 3 times 0.8 times 0.2. I told you 0.2 was from 1 minus 0.8, 1 minus the probability, p. Then how much will be the standard deviation? Anybody? 0.69? 0.693. Very simple. We don't have to apply the 6 steps. Yes, you know the binomial distribution is one of the discrete random variable, so why not? Yeah, originally we just applied the formula to get the mean, to get the standard deviation, 6 steps. We can take the same standard deviation, 0.693, but we don't have to do that. Simply just to take the square root of n times p times 1 minus p. It will be the standard deviation based on the binomial setting.